Hello and greetings to everyone. We have the following questions to answer. Question 1 says write down the following numbers correct to the required number of decimal places. You can see the numbers. We have to write this one to 1 decimal place, this other one to 3 decimal place, and this other number to 4 decimal places. Let's answer the questions. Write down solution. Question 1. For A, we have the number 0.0078 to 1 decimal place. If we are given a number, for example, let's assume we are given a number 4.973025. When counting the number of decimal places of this number, we simply count the digits after the decimal point. This number has 1, 2, 3, 4, 5, 6. It has 6 decimal places. This is the first decimal place. This is the second, the third, the fourth, the fifth, the sixth. If we are to write this number to 1 decimal place, we are going to count the first decimal place. This is 1. Then we are to round off between the first and the second decimal place. So in between these 2 decimal places, we are to draw a vertical line as such. And the digit which comes immediately after the vertical line, if the digit is greater than or equal to 5, that means the digit is 5, 6, 7, 8, or 9, it is rounded up to 1. Then we are going to add the 1 to the digit that comes before the vertical line. Then we replace all the other digits with zeros. But if the digit is less than 5, that is, if the digit is 0, 1, 2, 3, or 4, it is rounded down to 0. And the digit that comes before the vertical line remains unchanged, and we replace all the other digits with zeros. Let's go back to our question. So we have to write the number 0.0078 to 1 decimal place. This is our decimal point. So to 1 decimal place, this is the first decimal place, the second, the third, the fourth. So we have to round off between these 2 zeros. So 0.0078. We have a vertical line here. The digit that comes after the vertical line is a 0, which is less than 5. So it is rounded down to 0. And the digit that comes before the vertical line will remain unchanged. Then we replace all these other digits with zeros. So this will be approximately, it is an approximation. They are not the same. So this will be approximately 0.0 to 1 decimal place. You can see the result has just 1 decimal place. Next, for question D, we have the number 0.7471. We have to write this number to 3 decimal place. Writing this number to 3 decimal place, if we write the number 0.7471, this is the first decimal place, the second, the third. So we have to round off between 7 and 1. 1 here is less than 5, so it is rounded down to 0. The digit which comes before the vertical line remains unchanged. 0.7471 is approximately 0.747 to 3 decimal places. This is the result. You can see it has 1, 2, 3 decimal places. For question C, we have 99.99998. We have to write this number to 4 decimal places. This will give us 99.99998. To 4 decimal places, if we count, this is the first, second, third, fourth. So we have to round off between 9 and 8. 8 is greater than or equal to 5, so it is rounded up to 1. We are going to add the 1 to this 9, to the digit which comes before the vertical line. We know 9 plus that 1 gives us 10, so we cannot write 10 here. We are going to write down 0, then we carry the 1 to this other 9. 9 plus 1 gives us 10. We are going to keep a 0, we carry the 1 to this other 9, which gives us 10. We are going to write the 0, we carry the 1 to this other 9, which gives us 10. We are going to write down the 0, then we carry the 1 to this other 9 here, which gives us 10. We write 0, we carry the 1 to this other 9, which gives us 10. So in this case now, we can write down the 10. So this will give us 1, 0, 0. Here, we write down the 10. We have 1 with 0. Then we replace this other 9 with 0. Point. Here we have zeros. 0, 0, 0, 0, comma, 2, 4 dp. It's an approximation. So this is the result. Next, for question 2. Question 2 says write down the following numbers correct to the required number of significant figures SF. Question A, we have 0.0086 to 1 SF. Let me explain something. When a number begins with zeros, as such, these zeros are not considered to be significant figures. The only case where we consider a zero to be a significant figure is when the zero is found in between non-zero digits, or when the zero is found in a whole number. For example, a number like let's say 10,000. These zeros here, they are significant figures. In this case, this our number has 1, 2, 3 zeros. It begins with zeros. These 3 zeros here, they are not significant figures. Our first significant figure here is the first non-zero digit, which is 8. Writing this number to 1SF. This is the first significant figure. So we have to round off between, I'll draw this vertical line. We have to round off between 8 and 6. 6 is greater than or equal to 5. So it is rounded up to 1. We are going to add the 1 to this 8, which gives us 9. So this will be approximately 0.009, to 1 significant figure. Next, for B, we have the number 369.047. We have to write this one to 4 significant figures. 369.047. Here, the first significant figure is 3. You can see that this number begins with non-zero digits. This is the first significant figure. The second, the third. This 0 here, which is found in between non-zero digits, is a significant figure. This is the fourth significant figure. This is the fifth significant figure. This is the sixth significant figure. Writing this number to 4 significant figures, that means we have to round off between 0 and 4. We have to round off here. 4 is less than 5. It is rounded down to 0. This 0 will remain unchanged. So this will be approximately 369.0 to 4 significant figures. It remains unchanged. You can see this side, we can replace these other digits with zeros. There is no problem. You can put zeros here, these other digits, 2, 4 significant figures. Next question, question C. We have the number 2, 4. We have the number 78,958,100. We have to write this number to 4 significant figures. Write down the number. First, we need to count the 4 significant figures. We start counting the significant figures from the highest place value of the number. So we start from the left hand side to the right. This is the first significant figure, the second, the third, the fourth. We have to round off between 5 and 8. 8 is greater than or equal to 5. So it is rounded up to 1. We are going to add the 1 to this 5, which gives us 6. Then we replace all these other digits with 0. So this will be approximately 7, 8, 9, 6. Then we are going to replace all these other digits with zeros. Replace 8 with 0, 1 with 0. Then these other zeros will remain unchanged. Number 2, 4 significant figures. We are done. Next, question 3. Question 3 says write the following numbers in standard form. Writing a number in standard form simply means we have to write a number in this form. We are given a number. If we are given a number n, we have to write the number n in standard form. That means we have to write the number in the form a times 10 to the power n. For a, for this our a lies between 1 is less than equal to a, less than 10, strictly less than 10, and n belongs to the set of integers. A can be 1, but a cannot be less than 1, and a cannot be greater than or equal to 10. Let's take for example, if our a is 10, we will have something like this: 10 times 10 to the power n. And in this case, we can make use of the laws of indices. A to the power n times a to the power n is equal to a to the power n plus m. In this case, this will simply give us, we know 10 years to the power 1. This will give us 10 to the power 1 plus n. Finally, it is not in this form. You can see 10 to the power 1 plus n is not in the form a times 10 to the power n. So that's why our a cannot be greater than or equal to 10. Next, let's proceed to, let's answer the first question, which says, is write down the number. We have this number. It has 5 zeros. Okay, 2, 4. So we have this number 462,400,000. So we have to write this number in standard form. That means we have to write this number in the form a times 10 to the power n. First thing, we know that all whole numbers can be expressed with decimal point. So this number we can express it as such: the 5 zeros, 0.0. For us to get our a, we know a lies between 1 and 10. A can be equal to 1, but a cannot be equal to 10. For us to get the value of a, in this case, we are going to take the decimal point, 1, 2, 3, 4, 5, 6. If we end here, we are going to have a 462.4, which is already greater than 10. So we are going to take it down. 7. If you end here, it gives 46.24, which is still greater than 10. 7. 8. If we end here, this will give us 4.624. Since all these zeros after 4, they have no use, we can dump them. So this will give us 4.624, which lies between 1 and 10. But if you decide to end here down, this will give you 0.4624, which is less than 1, of which a cannot be less than 1. So this will give us, we are going to move 1, 2, 3, 4, 5, 6, 7, 8. We are going to move 8 places to the left. And these 8 places, the 8 places we move to the left, gives us the power of 10. So the power of 10 will simply be 8. When the movement is to the left, it is positive. The power is positive. When the movement is to the right, the power is negative. This will give us 460,400,000 will simply be equal to, our A is simply 4.624 times 10 to the power. The movement was done to the left, 8 places to the left. And this will give us 4.624 times 10 to the power 8. Take note, when the movement is done to the left, the power is positive. When the movement is done to the right, the power is negative. Now B, for B we have the number 0.0000, that's 5003754. We have to express this number in standard, let's write this number in standard form. First, in this case, if we take this number 0.00003754, in this case, for us to get our value of A, we are going to do our movement to the right. So we are going to take this decimal point 1, 2, 3, 4, 5, 6. We are going to end between 3 and 7. So this will give us a 3.754. If we end between 7 and 5, this will give us a 37.54, which is greater than 10. And we know A cannot be greater than or equal to 10. So when doing a movement, you do it in such a way that you will have your value for A, which lies between 1 and 10. So we are going to move 1, 2, 3, 4, 5, 6. 6 places to the right. The power will simply be negative since the movement was done to the right. This will give us 0.0003754. In standard form, it will simply be equal to 3.754 times 10 to the power negative 6. Since the movement was done to the right hand side, negative, the power will be negative. Question C, the last one. Yes, we have the number 38,359.002,872. In this case, we have to express this number in standard form. You take note, in this case is somehow tricky, very tricky. In this case, if you decide to move to the right hand side, instead you will discover that you will never get the value for A. You will never have the value for A if you decide to move to this direction. If you decide to move to the left hand side, it is very easy for you to get the value of A. So getting the value of A, we are going to move 1, 2, 3, 4. We are going to move 4 places to the left hand side, of which this will give us the number 3.8359. We are going to put these zeros because these zeros are found in between non-zero digits. So we are going to put the zeros 2872. We are going to put all these digits. This will give us 38,359.00287 in standard form will simply be equal to our value for A. This is our value for A, 3.8359.00287 times 10 to the power. We move 1, 2, 3, 4. 4 places to the left hand side. Remember, when you move to the left, the power is positive. This is the result. And we are done with the solution of the questions. If in case you have any worries, make sure you ask your questions at the comment section. Thank you very much for watching.